channel, and in this video we are going to see red black tree. Red black tree is also a binary tree, but the speciality which lies in this is it is self-balancing binary tree. Self-balancing binary tree where the height of the tree is never beyond order of log n. What it means is its height is maximum log n. It can't be greater than this. So since log n is a very small value when compared to n square, 2 power n square, n power n. So this is a very small value when you compare it with them. So because of the short height, its advantages are in efficient searching and also insertion, and third comes the deletion. When you search for an element, if the tree is short, you can find it very easily. Suppose I am taking a random number like 4, 3, 5 and 2 over here and 1 over here and 6, 7. Suppose if you want to search the number 1. Now since this tree is short, you can search it easily. If you are having more number of levels, it would become more complex. So that's what it's trying to tell us. So because of the short height, we can easily find out an element, or we can easily insert or delete an element. Now coming to the properties of red black tree, there are 5 properties. If a tree satisfies the following properties, then we can say that the following tree is the red black tree. The first property says the node color. Each node is either red or black. Suppose you are having 2 nodes A and B. So they can be either red or they can be either black. The second property states that the root of the tree is always black. Suppose you are having a tree like A, B, C. In this the root element is called as A. So this element is always black in color. The third property says that the red nodes, it cannot have red children. Suppose you are having B and C. Suppose they are red in color, so they can't have their red children. If they are red, so this is not possible. So that's what it is trying to tell us. The fourth property states that every path from node to its descendant null nodes has the same number of black nodes. That means if we start from A, B, C, suppose this is just a random thing which I am taking, D, E, F, G. So these are all the paths which the tree can traverse from the root to below. So the number of black nodes in each path is same. Suppose if you catch the first path, that is A, B and D, the number of black nodes, suppose there are 1 black node. So in all the paths, the number of black nodes should be 1. Then only it satisfies the property of red black tree. Now coming to the last property, the leaf property. All leaves, null nodes are black. Okay. Suppose you are having a leaf node G. Suppose this is in the red color, but its children, they are hidden actually. They are not always written, but they are the hidden children. So they would always be black in color, and that's what it's trying to tell us. Now let us see with an example that whether a tree satisfies the red black tree properties or not. Coming to this tree, it is having white circles. The white circles represent the black nodes and the red circle represent the red nodes, and the last are the null nodes. I already said you that they are the leaf nodes. They are like leaf nodes and they are always in which color? Black color. See, for all the leaf nodes, the two sides there would be filled with nil, and this is important to know. Okay, when you come to 15 or 1, so all the leaf nodes are filled with nil nodes. Now coming to its properties, the first property is each node is either red or black. So coming to every single node, it is either red or it is black. So first property is satisfied. The second property says that the root node has to be black. So which color is the root node here? It is black. So it has satisfied two properties. Coming to the third property, it says red nodes cannot have red children. That means now here the red nodes are 8, 6, 17, 22, 27. So they cannot have red children. So 15 and 25 are the children of 17. So they cannot be red in color because their parent is in red color. So that's the reason they have to be black. So it has satisfied this property also. Now coming to the fourth property, it is every path will have same number of black nodes till the descendant nil nodes. So now if you calculate the paths, now I'll tell you how do we calculate the paths. So here there are first path is from 13 to 6. I'll tell you how you calculate a path. This is the path 13 to 6. The traversal you do to move from 13 to 6. The second path is from 13 to 11. The third path is from 13 to 15. The fourth path is from 13 to 22. And the fifth path is from 13 to 27. So this is how all the paths are divided. And now in this we need to calculate the black nodes. From where to where? From the root node to the leaf null nodes. These null nodes are there. Now till there we need to calculate the number of black nodes. So from 13 if you calculate up to 6, then there are how many black nodes? 13 and 1. So there are 2 black nodes. From 13 to 11 also there are 2 black nodes. Now from 13 to 15 there are still 2 black nodes. From 13 to 22 there are 2 black nodes again, 13 and 25. The same goes with 13 to 27. Now you need to calculate these extra nodes also. From 13 to 6 we are having black nodes in the last level. So it's always the same number of black nodes in each path. Here 2 black nodes extra. Here also we have 2. For 15 we are having the other 2. For 22 we have the other 2. For 27 also we have the other 2. So in all of these you will add plus 2. Plus 2 for each path. Because each path is having 2 black nil nodes. And we need to calculate it up to nil nodes. The black property says this. So it is satisfied. Now coming to the last property, it says that all leaves are black. So here the leaves, he has said that the leaves are nil nodes. So all the nil nodes are black in color as it is in the property. So this red black tree has satisfied all the 5 properties. So this can be concluded as red black tree. If it dissatisfies any one of the property, then it would not be considered as red black tree. Hope this concept is clear with you. If you like the video, then do share it with your friends and don't forget to comment your opinions below. If you are new to this channel, then don't forget to subscribe to my channel and see you in the next video. Until then, bye bye.